Hello everyone, welcome to this Rockwell Allen Bradley Modbus TCP test video. And in this video, I would like to show how can we implement the Modbus TCP Client function in the CompactLogix controller. And we will use this Modbus TCP Client add-on instruction AOI, this client function. The Modbus TCP Client means this function block will run as a master, so it can send the data to the other side or receive the data from the other side. So the client and the master, this is the same idea. And as shown from this menu, so this AOI can be used for the CompactLogix and CompactLogix. And we can download this AOI from Rockwell Automation website. To download this AOI, we need to browse rockwellautomation.com. And then from this search area, we can type in Modbus TCP. And then click search. And keep in mind, we select the sample code here. And then we will find this AOI, Modbus TCP add-on instruction. And this is the latest version, that is a 2.02. A update from October 28, a brand new. One old version, a update before, that is a version 1.03. Highly recommend we use the latest version. And then you can download. And this AOI can be used for free. And once we download the file, we need to run the execution file and then unzip the file. We will find there are two menus here. One is the Modbus TCP Server, one is Modbus Client. And there are two AOI here. And in this video, we will mainly focus on the client function. And inside this menu, there are a couple important information I would like to mention. So this is that menu, Modbus TCP Client AOI. And this menu has 20 pages. It's easy to understand, and you can quickly preview and quickly understand how it goes. And firstly, we need to take care about this. So this AOI supports the logic controller is version equal or greater than 20. Some old version, for example, L33 CompactLogix, it doesn't support this. So keep in mind, your controller must support the open socket, basically open TCP. You can check out this link and search this ID number so you can find the compatible list of your controller. From the Rockwell Automation, this website, if we search the ID number 470690, so we can click the search and find this sample code, this description for this Modbus TCP master and slave function. And we will find for the version 2.00, so this is the environment, the controller, this AOI supports. Okay, make sure your controller support this. So basically, the new version controller, CompactLogix or CompactLogix, or greater than version 20, they all support Modbus TCP. And also keep in mind this, the first instance of the Modbus TCP client, it will use 93K memory. And the additional AOI will use 20. So basically, if you only use one, it still takes 93K memory. For example, the L18, probably the memory size is just around 300 or around 400K. So basically, the 93 will take a significant amount of the memory. So you need to be very carefully about this, especially you already have one existing program and you have to use the Modbus TCP client to implement this function. So take care if your controller memory is enough to implement this AOI, okay? And in this test, we will mainly use the function called 03. 03 will allow the client to read the data from the server side. And we will use the 16. The 16 will write the data from this client side to the server side. Function 03, it can read multiple data register. And function 16, it can write multiple register. The telegram, that frame, basically the longest data we can send or read, that's the 120 register. Each register, that is a one word. The 03 and the 16, they are common used code for reading and writing. And when we import this AOI, you must carefully about this word. Use only the run import process. After the import, we cannot copy, paste, or rename. We better import directly, especially after you import the first one and you need to implement the second client. Keep in mind, you need to import rather than use the copy paste. keep in mind some important nodes in this menu. So we need to run this import. I will show how we can do this after. And the last but not the least, I would like to mention, for the multiple instance, for example, in your controller, you need to implement two clients. That means there are two server modules outside your controller, and you need to communicate with them at the same time. So that time, for the instance, the name, we must use the individual name. We cannot just copy paste and use the same name. Keep in mind the structure name there. Keep in mind the message tag we need to rename. We can now use the same name. Okay, let's turn to the Studio 5000 side. Let's implement this function, this Modbus TCP Client AOI. Okay, firstly, I would like to open the RS-Link Classic. Okay, from this Ethernet drive, this link, my controller I'm using, that is a 1769L33, and its IP address is 1.101. So in this test, it will run as Modbus TCP Client. Okay, so let's open the Studio 5000. Click this new project. Let's set up the project. So select the controller you are going to use, and here, so I will name this project CompactLogix Modbus TCP Client. Okay, click OK. And the studio version I'm using, that is 32, and this version match with my actual controller. And in the meantime, you need to prepare the AOI file we download. In this test, we will use this Modbus TCP Client run, and you can follow the menus, and my task will basically follow this menu also. Alright, let's go to the main program. Okay, and here, let's right click, click add a new run. So here we can name it Modbus TCP Client. Okay, and from this main routine, we can call this subroutine. So here, double click, we can type in GSR. So use the GSR to call the subroutine Modbus TCP Client. Okay, and all our program will be within this subroutine here. And at here, let's right click, click this import runs, and click this Modbus TCP Client underscore run.l5x, this file. Okay, and click the open. So you need to make sure while using this import this way, you cannot copy from other project. You better not copy from the other project. Okay, use this import. Okay, and here this is a create. Okay, we will select this create. Let's click OK. So after the import, it will show like this way. And after we import successfully, we can follow the menu. So we will find the reference connection here and click the monitor. So we need to set the important parameter under this UDT, this parameter variable list. And we can also see that after we import, so from this add-on AOI, this area, it import the user defined and import the string. Also from this AOI instructions, it imports a lot at here. That's why it will take 93K. It actually did a lot of job behind. Follow the menu. So from this reference connection, we can right click, click this monitor. So we can jump to the variable, this area. And this parameter is very important. We need to set the value here. So expand that. And keep in mind, we are under the monitoring tags. Now we are offline. So write the data here, it can directly prepare the parameter for this variable. Okay, so firstly, local slot. This local slot for the CompactLogix, basically it is 0. That's 0 we can find from our hardware list here from this I/O configuration. So we need to select the actual TCP port, where that TCP comes from. For the CompactLogix port, all the Ethernet IP port, they are built in, that come from the controller. So this controller, that index number is 0. Here we will select 0. If you are using the CompactLogix controller, you need to carefully about that. So for the CompactLogix, we need to select the slot come from the EN2T, that module. Keep in mind this, okay? And the local address, basically, we can leave as empty. You need to read that menu. In case you are using the durable IP mode, you need to set something here. But most of the cases, we will leave it as empty here. And this destination is very important. Now our controller, our IP is 192.168.1.101. And from the Modbus server side, I will use my laptop and I will use the Modbus slave, the simulation software, and simulate as a Modbus server. So this IP address will be my laptop IP address. So at here, we can click this small button. And at here, we can type in the IP address, 1.201, okay? So this is my server side. And this client, our PLC, is a 1.101, okay? Okay, and the destination port. So this is our server side port. And 502, that is a common used port for the Modbus TCP. Basically, we will leave this port here, okay? Okay, so we finish the important parameter here. And then let's go to the function block side. At here, this enable. So this enable will control if we active this TCP client. So keep in mind, we will set 1 to make sure we enable this function. And then let's go to the next, that reference transaction. So right click this monitor. We can look at the detail value within this transaction. So what the pooling interval time, we need to send the data. So we can expand this. Okay. So this pooling interval, that is the interval time every time we send the data or request the data from the server. So what the value we can set at here, that depends on your application. Sometimes if we need faster to fetch the data from the Modbus TCP server, so this time you can set a shorter. However, after all, this is the Modbus TCP. That is not actual real-time communication. Sometimes if you set it too short, actually the function block cannot run that task. So you need to read the detail from the menu. So for this 10 milliseconds periodic task here, if we run one transaction, so the interval time we better set greater or equal to 80 milliseconds. So this minimum pool interval time, that will be the 80 milliseconds. So keep in mind this, typically we can set 200 or 500 milliseconds. We can now set too short. Also keep in mind this is a periodic task. It's highly recommended we can import this function block into a longer periodic task. So I will change this function block location into another longer periodic task. And keep in mind, this pool interval time, we cannot too short. In this test, we can set 200 or 500 milliseconds if we are using one transaction, okay? So let's go back here. So in this test, we can set 200 milliseconds. And this trans type, if required from the menu, that is the actual function code we need to use. So in this test, we will test 03 and 16. We will type in the 03 and 16 into that trans type. And keep in mind here, if we are using one client, so when we active the 03, so the server data will be wrote into this 40,000 this address. But when we try to write the data, it will still using this 40,000 address, write the data from this area to the server side. So when we use the 03 and the 16, they are sharing this address, this area. So we need to work carefully about this. Sometimes you will find after you read the data and then you send the data, actually you send the same data back to the server side. We need to take care about this. So we need to take care about this. I will show how can we use this. The basic idea is that from this 40,000, this Modbus register this area 120 length. So we need to separate this 120 length into a basic two area. One is used for reading, one is used for writing. From this transaction 0, we will use the 3 here. We will read the data from the server side. Okay, and this UDT, And keep in mind, this UID is an integer number here. This UID is very important for some third-end module. So sometimes some manufacturer will preset the value to FF, that is a hex value, the integer value that is a 255. You need to check the manual from this module and check out the inside UID setting there. So by default, we will leave 0 at here, but you need to take care about this. Sometimes everything setting, they are correct, but you cannot get the Modbus TCP connection successfully. That's because this. So you need to carefully about this. And next, the beginning address and the counter. This is very important, especially if we are using 03 function code and 16 at the same time, because 03 and 16, they are sharing use the 40,000 that Modbus address area. So we need to set this beginning address and the counter correctly. For example, if we review this menu at here, the beginning address here, if we set 1, for the 03, this function code, that means we will start 400,001. We will start from 1, and then this is the length. And if we are using one client and a 03 function code and a 16, they are sharing use this address area. So we need to separate the entire 120 into 2 individual area. For example, in this case, so if we go back to the program, and at here, the beginning address for the reading, we can start from 1, and then the counter we can set 20. And then from the next transaction, this pooling interval time we can set 200, also the same. And this transaction type we can set 16. And at here, the beginning address, so we can set the 21. And the length, we can still use 20 register. So the register is a word. Okay, so that means here, that is the 400,001 start until the 20. And this writing area, we will start to use from the 21. And that Modbus address length, that is a 20. Okay, and then this local address. So as we know, this address, that is a 400,000 that address, Modbus address. But there will be an image address, that mapping address reading from the Modbus address to our PLC local address. The local buffer address, if we go back from this function block, and we will see this is the PLC Modbus mapping address, this memory area. So let's right click this monitor, and we will see here. So it has the coil, descript input, so input register and hold register. Like we said, if we are using the common used 03 and 16 function code, so the Modbus address image mapping area, we will use this number 4 area. We need to set, that is the index data. We try to match the Modbus address. We can set the start address that start from 1. And for reading the data from the server to this client, the length is 20. So we will start 1 to 20 here. And we send the data from this client to the server side, we will start from here. And the length is 20. But keep in mind here, since the PLC start from the 0, this index from this array, that start from 0. But the Modbus address that start from 1, that really confused. But for testing purpose, we will set the same number as this beginning and the local address. So I will set 1 at here. I will discuss this when we are online test. This local address, we will start from the 21. So basically, we try to match this data. Okay, let's test that after. And also here, the enable. This enable will enable the different function code, the command. Personally, I highly recommend those enable cannot be turned on at the same time. You need to use the time slice to turn down individually and one by one. They cannot turn on at the same time. Otherwise, you will see the time override output will turn on from this function block. But for testing purpose, we can turn it on. I will show how this time overlap turn on. Okay, now we finish all the important setting here, and we can download this program and try this connection. And the last things, so as I showed, this Modbus TCP function block, we better call that with a longer periodic task, this main task, it will run very fast if we right-click, click this properties. And from this configuration, we can see this main task, that is a continuous task. We better create one individual periodic task, and the periodic task could be set to 20 milliseconds, for example. So that will cost our controller a less workload. So from this new task, we can click this new task, a named cycle 20 millisecond task. Okay, that is a periodic, keep in mind this. And the cycle time we set 20. That means once we start the controller, so this function block we need to call every 20 milliseconds. If we run continuous task, so every cycle it will call this function block. Basically, it will cause a too heavy workload for the controller. Okay, so click the OK. Okay, after we create this task, we will create one program folder. So create one program folder, new program. We can call that cycle 20 milliseconds, this program. Okay. And after this, let's create a new routine. That is the main routine. Okay. So that is the main routine belongs to this program. Okay. We can call the same name, main routine. We can drag this Modbus TCP client, this routine, under this cyclic task, this routine. Okay, here, drag under here. Say, okay, we moved here. So leave it empty and use this main routine under this cyclic task. Double click, right click, click the paste. Okay, so under here, this function block will be called every 20 milliseconds. And now let's click this compile. No arrow here. And meantime, we can click this controller properties. And let's look at this capacity. Because I'm using this 1769 L33, this controller. And this controller, its memory is really huge. We can see after we program this Modbus TCP, it already uses 76K bytes. If you are using a lower end controller, probably your controller only has 380K bytes. So basically, once you use this Modbus client, or maybe 20%, maybe 15% or 20%, this work memory already be used. So you need to work carefully about this. Okay. Okay, now let's download. So click this communication, and let's find out the controller I'm going to use. That IP address is 1.101. Okay, click this download. Okay, let's start the controller. Okay, once we start, make sure this run, that is green. That means this controller is calling, is running this function block. Okay, now make sure this enable is enabled. So set to 1. But now the status connected, it shows off. That's because we haven't set up the Modbus TCP server side. Okay, to set up the TCP server side, so I will recommend you can browse, go to the wintech.com and find out the software ModScan and ModSim. This ModSim will run as a Modbus TCP server. And the Modbus Scan, this software will run as a Modbus TCP client. In this case, I will use ModSim 64, this version. Alright, once we download the software ModSim 64, so the ModSim 64, that is the execution file, so we can double click. And currently my PC, the IP address in my PC, that is 1.201. So keep in mind, so from the client side, we need to set the same IP address, let the client to find this server. Okay, and this ModSim 64, we need to register, but for the short time testing purpose, we can still use that. So we click OK, and wait a couple of seconds, and click OK. And click OK. And then let's set up new configuration. Okay, here. And let's set up this connection. So we will use the Modbus TCP server, this function. And actually this software also can communicate with the RS-232 or RS-485. Okay, so keep in mind this Modbus TCP, this port, if we recall from the client side, we set this 502. That is the default port number for the Modbus TCP. Okay, click OK. And keep in mind, we better turn off the firewall when we're testing this, because probably your Windows will block this of 502, this port. So here, the address, that is the Modbus address, that is the 40,000 address. So we can start from 1. And the length, we can set the length 100. Okay, so once we set this, we can see this is the Modbus address. And now 03 here, it will show this Modbus holding register area, 40,100, this area. For those data, we are using the decimal or use the hex. And now this Modbus TCP server side, we are ready. And now once we shift back to the Studio 5000 side, we can see this status shows connected. That means this client find this server and is communicating here. Also, we can find here the system status overlap that shows on. That's because in the transaction side, we turn on 2 transactions at the same time. We enabled at the same time for testing purpose. So if we record from this setting, this transaction area, we go click this monitor, we can see we turn on those 2 transactions at the same time. That's why the system shows overlap. In actual cases, we better use the sequence control or the time slice to separate the send and the receive. The function code 03 and 16, we separate them to a different time. If we go back here, the actual data we need to send or read, that come from the Modbus data. Right click, click this monitor. This 21 here, we can prepare the data. So to test the data, I recommend we can start to use the hex, this hex value. So we can prepare, for example, ABCD. Using the hex, we can clearly see if the low byte and the high byte can be sent correctly. Sometimes the high byte and low byte, they will be reversed. And the next word, we can select the hex, and here we can set, for example, 4567. Okay, this is a hex, keep in mind this. Okay, and this area, that is the reading buffer. So we will read the data from the server. Now it received the data, but now here is showing as a decimal. So we can change this display style to hex. So once we switch here, we can see the Modbus address here is received ABCD. And this 4567 is received here. But here is one thing. So we can see, actually we want to send the 4021 to the Modbus 4021. It got a 1 off here. We can temporarily park here that received correctly, but the address got a 1 off. Let's double verify the reading data buffer. Let's verify this reading buffer. So here from the number 1 here, let's double click this 4000. And here we can type in the hex value. We can type in, for example, 3344. And next, number 2, that is a 5566. Okay, now we can go to the PLC side, look at here. And also we can toggle to hex value. So we can see the 5566 it received correctly, but the first one it didn't. That's because it also have a 1 off the address issue here. If now we type in the data at 3, so double click. For example, let's set 2266. Okay, we can see the 2266 it can receive correctly. And because we have a 1 offside, so the first one it didn't receive correctly. That key reason, that's because from the PLC side, it starts from the 0, this index. But from the Modbus address, it starts from 1. That's why it got a off here. So to fix this, we can go to the function block side. And then we can modify some settings inside this transaction. Right click, click this monitor. So to fix this offside, so this beginning address, that is the Modbus address. So we need to set a decreased one. So for example, if we start from the 40,001, so actually we can set the 0 here. And for this writing here, so this beginning address, we can set 20. And our local still 21. And then let's look at the data. Here in the PLC side, that is the 40,000, this address. Now we are reading the data from this server to here, and this Modbus address, that is a 40,001, and we receive the data as this 1, this index here. So if we set a new value here, double click and write a 7788, and we can see 7788 we received correctly. And next one, okay, and because this is the demo, so we need to close that and then restart that, and it will be very quick, so we can close it, create a new instant, double check the connection here, and set the number 1 start address. Okay, so we can reset the data here. Okay, we can send 7788 for the first one. Make sure that it's a hex. Okay, and next one, let's set 3344 5566. Okay, so as we can see, there's 3 data we sent to match this address here, the index number, so they are matching here. Okay, and the writing data, let's scroll down, and from the PLC side we start from this ABCD here, and we start from the 21 and its length is 10, so we send the ABCD, that is hex number, and the 4567 hex number, so we can see the 21 is received correctly, and this 22 is received correctly here. And we can also write the data, for example hex, so we can write 1234, the hex number, so it received 1234 correctly. Okay, if I shift to the decimal side, and now from this decimal, this 24, if we send 6789, so we can see the decimal value is received correctly. And now at this, the number 4, if we type in the value, the decimal value, we can send the 1234, the decimal value, and we can see the decimal from the PLC, so we can see the index number, they match. So to match this, because this address start from 0 and the Modbus start from 1, to match this, so the setting, if we recall, so if our local address we select 1, to match this address, at this beginning address we -1 based on this. That's why here that is 0. And here, so if our local address we select 21, this is our PLC address. So at this beginning address we -1, 20. So that allows this index number that match our PLC local address. Okay, alright, after this test, let's click this property and look at the capacity. And this is a pure program. And in this function block, we have a 2 transaction here. We also set up one 20 millisecond cyclic task to call this function block. So totally, this program takes 180K bytes. So that means for the smaller controller, you must be very carefully about this. And also we can double click this cyclic task and click this monitor, and we can look at the actual scanning time. Okay, the scan, basically it took 1 millisecond for this controller, but this controller is really powerful because that is an L33 controller that is really powerful. For the lower end CompactLogix, this time scanning time might be bigger. So if we put this program within the main task, the cyclic task, probably that will cause a longer time on the scanning time. Alright, that is the Rockwell Allen Bradley CompactLogix Modbus TCP Client function master function test. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.